Hey guys, it's Central Arkansas EAS here. Today is December 10th, 2024. Anybody in the weather community would know what December 10th means to me as a weather lover and a weather nerd anywhere. And for those who don't know, December 10th is the date in which there was a tornado, the deadliest tornado since the Joplin, Missouri EF5 in 2011. However, this tornado was not even close to all that happened during this outbreak. There was a lot that went down during this outbreak. One of my favorite YouTubers, Alferia, made a weather documentary. He does weather documentaries on his channel about this outbreak. And I'm today going to go through that weather documentary with you and just watch it. I watch it every year on the date of this December 10th, 2021 anniversary. Because December 10th, 2021 was a day that it's a day that I will never forget. I'll just put it that way. It was probably one of the scariest severe weather days I have ever seen in my life. I mean, you don't see a severe weather day that scary very often. Right. So, without further ado, let's go with this.
2021 was a year that was defined by a number of major weather events. From Hurricane Ida and its path of destruction from the Gulf Coast to New England, to extreme heat waves in the Pacific Northwest, to a fair share of tornado events such as the March 25th outbreak, where an EF4 tornado hit noon in Georgia. But if you were to grab some random person off the street and ask them what weather event they remembered from 2021, the answer you get is almost unanimous. They will respond with the Mayfield tornado, officially known as the Western Kentucky tornado of 2021. The Western Kentucky tornado is one of the most infamous tornadoes in recent memory, only rivaling the Joplin tornado in terms of public relevancy. The December 10th through the 11th tornado outbreak, which I will just be referring to as the December 10th outbreak from here on out, is known by most for just the Western Kentucky tornado, and just that tornado alone. However, the December 10th outbreak was so much more than just the quad-state supercell tornadoes. While yes, the Western Kentucky tornado is the most talked about tornado from this outbreak for a good reason, people often forget about the other major tornadoes from the outbreak that left people with nothing. 71 tornadoes were associated with this outbreak, 8 of those being EF3 or higher. Everyone knows Mayfield. Some people know Bowling Green, but nobody knows about the Pembroke, Kentucky tornado, or the one that struck Edwardsville, Illinois. A shame, considering those tornadoes were also important in the legacy this outbreak has. It has been roughly 9 months since the outbreak has occurred, and it
As of the day that he recorded that.
still feels like that the December 10th outbreak was just yesterday. In order to do this outbreak justice, one has to go over the outbreak in depth and look into what happened in Western Kentucky, but also outside of the tornadoes spawned by the quad-state supercell, as the tornadoes that occurred outside of Western Kentucky are just as important as to why the outbreak has the legacy it has. Today, I will be taking a deep dive into the December 10th through the 11th tornado outbreak, the background before the event, the synopsis, the actions taken by the Storm Prediction Center and National Weather Service Paducah and their respective roles in the outbreak itself, the aftermath, and the controversies surrounding the outbreak. Welcome to Nature's Fury.
Even though it's been 3 years on this day, that outbreak, as Alferia said, it does feel like it was just yesterday. I mean, it was... And the tornado that hit Edwardsville, Illinois, by the way, at this point in time, I was at home in Troy, Illinois at the time, where I used to live in Troy, Illinois. I had just actually returned home that weekend for the weekend from the school for the visually impaired, and that night was probably the scariest night of my life for a while, because that tornadic storm, it missed Troy by 5 miles, if that, maybe 5 to 15 miles. Missed my house by about 15 miles, which that's a little too close for comfort, considering that there were tornadic cells everywhere, all over the place. I mean, we had thunderstorms that were tornadic that stretched from literally Arkansas to central Illinois. It was not pretty. And then at the same time, we also had storms in Tennessee and Kentucky that were also producing tornadic activity. So it was definitely one of those outbreaks where it was like, oh no. And this is how it happened.
2021 was a weird year for severe weather overall.
Ain't that the truth, my friend? That is so true. We didn't really, in the Midwest at least, have a start during 2021 at least until after May. April was a very lull month. There was just nothing. It didn't feel like spring, honestly. I mean, it felt like spring. It was nice out and everything, but the weather was very absent and quiet. Almost too quiet, to be completely honest and fair. And May was average. May had average tornadic potential. And that's really when Mother Nature started to really wake up, at least in the Midwest. But then the season took an even weirder turn, as during the month of June and then every month following that up until October, we had a very large spike in the amount of severe weather that struck the United States. And that included some pretty significant stuff that normally wouldn't happen in some pretty odd places, such as an EF3 tornado near Philadelphia, Pennsylvania, as well as another significant tornado in Trenton, New Jersey. Yeah. I mean, New Jersey is not exactly known for tornadoes. Neither is Philadelphia, but they got them. 2 of them. In the span of a couple months. 2 of them.
While the year had an early start with severe weather activity, with an outbreak of tornadoes from March 16th through the 18th affecting Dixie Alley, and an outbreak of tornadoes from March 24th through the 28th, which included 4 EF3 tornadoes and an EF4 tornado that tore through Noonan, Georgia, the severe weather season quickly started to lose steam in April. April had a total of 79 tornadoes that year, the lowest number of tornadoes in the month since 1992. May's activity was average, with a total of 259 tornadoes touching down in the United States, mainly during an outbreak from May 2nd through the 4th. However, this was the first time in recorded history that the month of May saw no tornadoes of EF3 strength or higher. The majority of tornadic activity came from the months after June. From July 28th through the 29th, a total of 46 tornadoes touched down in the Great Lakes, Ohio Valley, and Mid-Atlantic, including an EF3 tornado near Philadelphia, Pennsylvania. Hurricane Ida's remnants in the United States caused a notable tornado outbreak, including an EF3 tornado in New Jersey. The storm then would produce another tornado, leading to NWS Mount Holly issuing their first ever tornado emergency in their forecast area. October had the most tornadoes for the month on record, with a total of 150. Most of those occurred from October 9th through the 13th, with most of those tornadoes being weak. However, the worst event for October occurred from October 24th through the 25th, where 2 EF3 tornadoes occurred in Illinois and Missouri. And after that, there was a quiet period regarding severe weather activity in the United States. Welcome to most after the unusual spike in activity in the month of October. But in early December, models began hinting at the potential for a severe weather event in the lower Ohio River Valley and Mississippi Valley. an event that would become the worst tornado outbreak ever observed in the month of December. But real quick, only a small portion.
So yeah, that is honestly scary. Just wow. Wow. Hold on, I'm curious what time it is. Okay, it's only 2:40 a.m. Okay, here we go.
Of the people who like these weather documentaries or subscribe to the channel, so if you enjoy the content I create, consider subscribing. It helps support what I do and tells me I'm doing something right. Anyways, back to the December 10th outbreak. The week before the event was supposed to occur, models were hinting at the possibility of severe weather at the end of the next week. However, anything specific regarding what could happen was not specified due to how far out the event was. 3 days out, the Storm Prediction Center noticed that there was enough confidence to begin issuing outlooks regarding the event in question, issuing a Day 3 slight risk for severe weather in the Mississippi Valley into the Ohio River Valley. However, no further upgrades were made for the rest of the day because there was a lack of certainty regarding the environment the storms would be in. However, as December 10th got closer, the expected severity of the outbreak gradually increased, as guidance became more consistent with what could happen on December 10th. The increased confidence led to a Day 2 enhanced risk being issued on December 9th, and then a Day 1 moderate risk being issued on December 10th. But what caused the upgrade to the moderate risk? And what was the general consensus with what was expected to occur on December 10th through the 11th? In order to learn more about how the outbreak came to be, and to learn the Storm Prediction Center's perspective on the event as a whole, I talked with a lead forecaster from the Storm Prediction Center, Richard Thompson, who issued the initial Day 1 moderate risk for the outbreak. He does a good job explaining what the general expectations were regarding the outbreak, and so I will hand it over to him to explain the setup. And I'll come in after to explain more of the environmental factors that weren't mentioned.
Okay, well, the initial moderate risk, so if we set the stage for what I inherited, when I walked in the door the morning of Friday, December 10th, there was an enhanced risk, which is a 3 out of 5 on our scale of outlook. So it's kind of in the middle, but that doesn't mean it's the most common one. So an enhanced risk is a little bit more than average. That's not just a normal severe weather day. So we've already got kind of a beefed up severe weather threat anticipated. It covered an area, most of the middle Mississippi Valley down into at least Arkansas, maybe the Mid-South. So we're talking Illinois, Missouri, Arkansas, parts of Tennessee, northern Mississippi. That sort of area was in the enhanced risk. It maybe went a little farther northeast. But so in looking at that, we had the basic setup where there's a storm system, mid to upper level shortwave trough, moving from the Rockies toward the Central Plains. Associated with that, we had a surface cyclone that we expected to develop from, roughly the Kansas-Colorado border to roughly northern Missouri by the evening of the 10th. And so in that basic scenario, if you have a storm system forming east of the Rockies, broad scale southwesterly flow aloft, that's a good scenario for what we call lee cyclogenesis, something to the east of the mountains. That also is going to induce strong southerly flow areas to the east and southeast of there, which brings in, potentially brings in moisture from the Gulf of Mexico basin if it's present down there. The thing that isn't usually the case in December is we don't have a broad, moist air mass sitting down close to the Gulf Coast very often. Like right now, it's everywhere. Moisture's all over the place down there. But in December, usually there have been frontal passages and things, and it's cooler and drier. The thing about that day is we did have pretty high moisture. Some of the dew points and things were not too different than what they are today down in the south. It was a little bit lower than what we have today. It's not nearly as warm, but it was moist all across the Gulf Coast into East Texas, and then up to about, say, the Louisiana-Arkansas border. So the southern United States had dew points in the 60s all over the place down there. That's a little unusual for December. So my initial impression there was like, okay, we have a weather system coming out of the plains. We've got a surface cyclone. We've got strong wind fields. But the thing that we're normally missing is the broad area of low moisture. So it's like, okay, that raises a red flag for me, so to speak, that we have potential that could be a little better than normal if everything works right. Now the problem became, okay, we have all this moisture. we'll have some instability, with this. But the question is, when and where are we going to get storms? And I think that's where most of the effort in the forecast, from my perspective, went into that outlook upgrade was, okay, what can I focus storm development on as we move forward? And to me, what caught my attention in this and largely was responsible for the upgrade was there was a little embedded speed max. I'm looking at like water vapor imagery, if you're familiar with it, and there was a hint of some kind of embedded jet streak back to the west. This was coming out of the southern plains, like out by Lubbock, somewhere out there in West Texas. If you just tried to figure out, you tracked it back 12 hours and then you extrapolate forward, it looks like it's going to be over Arkansas by evening. Okay, so I've got this embedded feature, not just broad flow, but there's something embedded in the flow that's going to move across Arkansas. And it looks like there's a little area of ascent. There's a little enhancement of the moisture. Basically, there's something I can track. And so now I'm looking more closely at Arkansas. I'm saying, wait a minute, we might, instead of getting storms all after dark, we might actually get storms formed during the afternoon over Arkansas. If they form in Arkansas during the afternoon, they're going to be in a much more interesting storm environment for much longer. So it gets into the duration of the severe threats. Because we thought, if you plop a storm in the right place, there's a tornado threat. But you have to get the storms in the right place to realize the threat. So I think what the upgrade was for was it started to look like we had an excuse to get thunderstorm development farther southwest and earlier than the original outlooks expected. They were looking at primarily an overnight event. And I know the Mayfield tornado was after dark, but look at where that storm formed. It started southwest of Little Rock, and it started during daylight. So that was the sort of the key for me. I said, we've got a scenario where I think we're going to get storms during daylight. That's going to push this threat up higher than we were originally thinking. So that was kind of what I was focusing on. And that's where the moderate risk came from.
With a general synoptic setup established, let's go a bit further in depth with the environment itself. The event is categorized as a low cape, high shear tornado event. ML Cape was expected to be anywhere from 1,000 to 2,000 joules per kilogram, adequate for severe thunderstorm development and intensification, especially in December. Shear was expected to be high for the event, with effective bulk shear in excess of 70 knots and the effective storm relative helicity being in excess of 300 meters squared per second squared. What also would aid with the shear was the expected formation of a low-level jet over where the supercells would eventually track.
So, to explain some of the numbers and things that he's throwing around, don't worry, I had to look a lot of these up as myself. Basically, CAPE is your instability value, and 1 to 2,000 joules per kilogram is pretty low in the relevance scale. However, in December, as he said, that's pretty adequate for thunderstorms to just explode in intensity, which is pretty much what happened. These supercells they formed and poof, exploded, and they kept going and going and going and going. I mean, it was crazy. Storm relative helicity, that's basically the potential energy that storms can use to feed off of once they do get going. And 300 meters per second squared, 300 meters squared per second squared, that's a pretty good amount of potential energy, especially in the month of December. Now, bulk shear, wind shear anyway, is the changing of wind direction and speed based off of different altitudes. And this changing in wind direction aloft is what allows for thunderstorms to start rotating. In fact, it is the biggest ingredient in creating the supercell. Because without the rotation, you don't have a supercell. You just have a thunderstorm. And once you get the rotation, that's what creates the tornado. You have the supercell spinning, the updraft lowering to the ground, forms a funnel cloud, and you get a tornado that touches down to the ground. I know that's very, very, very basic explanation of how a tornado forms and touches down, but it's sufficient enough in this scenario. But yeah, the environment was definitely not looking great. It was looking like something bad was going to happen.
Instability combined with the shear would favor the development of supercell thunderstorms capable of producing strong tornadoes and large hail, initially. The threat of stronger tornadoes was expected to diminish in the night as the supercells would grow in size and form into a line or be absorbed by a main line of thunderstorms that was expected to form along the cold front. The threat afterwards was expected to be defined by strong winds and tornadoes from embedded supercells in the line. Moisture and heat was expected to be unusually high for the time of year as well. Dew points were expected to reach into the 60s across multiple areas within the enhanced risk before the storms were expected to form, and temperatures were expected to reach into the 70s across most of those areas as well at some point during the day.
Yeah, St. Louis's high temperature that day turned out to be 81 degrees. 81 degrees in the month of December. The highest dew point that they saw that day was 71. That's a typical dew point and temperature ratio usually seen in early summer. So Mother Nature was cooking up something really bad.
CAP was also in place in the areas that were expecting storms. This would allow for additional heating and further destabilization of the atmosphere across Arkansas, the Mississippi Valley, and portions of the Ohio River Valley.
So a cap, you might be wondering, okay, what's a cap? Cap is basically an area of stable, dry air aloft. And this keeps thunderstorms from forming because they try and basically get these cumulus clouds at the surface that try and bubble up and they encounter the cap. Well, the cap is basically dry air. So it absorbs the water and the storm clouds fall apart. But once the cap erodes, which does happen throughout the day, as the atmosphere heats up and becomes more and more unstable, that can allow for thunderstorms to eventually, what they call, break through the cap and explode in intensity, which is pretty much what happened here. And as he said, there was a cap in place over pretty much most of Arkansas, Mississippi Valley, which included Missouri, Illinois, Tennessee, North Mississippi, that area, and then into the Ohio River Valley of southeast and southern Illinois, West Kentucky, central Kentucky, southwest and south central Indiana, and into Ohio. So there was definitely something going on.
Eventually, storms were expected to break through the cap, intensify rapidly, and then track across Arkansas and then the Mississippi and Ohio River valleys. But I also wanted to know what the expectation was for Western Kentucky from the source directly. So I interviewed Christine Welgos, the warning coordination meteorologist for NWS Paducah. She stated that NWS Paducah was aware of the situation and that people were starting to get concerned in the forecast area about what could occur.
Well, one thing you have to realize is that at our office, we have a lot of people that have been around a very long time, decades. So you have a lot of experience at this particular office. And so our office is pretty conservative. So we don't, go and cry wolf right away. We take a more gradual approach when it comes to something like this. We're very cognizant of our partners, the public that we serve. We don't like to cry wolf. We don't like to yell uncle right away, right? So it's one of those things where it was a progressive thing for us. We knew the ingredients were there. We knew the system was potent. We knew everything was there. We just didn't know, exactly how it was going to unfold. But we knew that the threat was there. Obviously, along with SPC, the Storm Prediction Center, they very gradually ramped up the event. So I think it was a gradual thing. And I was actually scheduled for vacation that week. But I was keeping track of everything. And it was probably Wednesday, Thursday that I started getting really concerned. And, I work with, some of these folks out here for a long, long time. And so you get to know, when you ask them, so what do you really think? And I remember talking to one of the forecasters, I think it was on Thursday, and he's like, Christina, doesn't look good at all. If it comes to fruition, this is going to be horrible. Even the day before, on December 9th, I went up to Henderson, Kentucky, because it was actually Winter Weather Awareness Week in Kentucky that week. So I had already slated to do a Facebook Live in Henderson, Kentucky, to talk about winter weather. And the ironic thing was that nobody wanted to talk about winter weather, obviously. Everybody wanted to talk about, what was going to go on the next day. And I'm like, okay, listen, guys, I understand. And you know what? Once we get, done talking about winter weather, get that out of the way, I will spend as much time as you guys want to talk about tomorrow. And that's exactly what we did. And that was rather interesting for me to think, okay, the public is heightened. They're scared, and it's our job to try to calm them down, try to make, practical suggestions on what to do and, where to go and safety and all that. So it was, pretty evident even the day before that people were ready. They were paying attention. They got the word. And that was what's, one of the reasons why we didn't have 3 times as many deaths with this event, because people were paying attention.
To the north of the
Yeah.
severe weather was a winter storm that had already brought record low temperatures to portions of the western United States. The winter storm was expected to bring substantial snowfall across the northern portions of the country, across the Dakotas, Minnesota, and then into Canada. With the general synopsis and expectations covered, December 10th came, and the events began to unfold.
I just find it ironic that it was actually Winter Weather Preparedness Week in Kentucky at this time. So they were trying to prepare people for winter-related hazards such as snow, freezing rain, sleet, and, the slippery roads and everything. Like, it's just kind of ironic that it's Winter Weather Preparedness Week, and the next day they get hit by a tornadic activity event. I mean, just goes to show that Mother Nature is unpredictable, people.
As December 10th came, the expectations from the Storm Prediction Center regarding overall storm conditions were beginning to be confirmed. As a trough moved through the Central Plains alongside the forming surface cyclone, dew points were reaching into the 60s and 70s across the southern United States and into Arkansas, Missouri, Illinois, Indiana, and Kentucky. Warm temperatures into the 70s were also present across those areas by midday. A strong mid-level shear was also present across the area, with bulk shear ranging from 80 to 90 knots at the 500 millibar level across Missouri, Illinois, far western Kentucky, and northern Arkansas. A low-level jet would soon be established across the areas where the quad-state supercell would travel, with winds of over 65 knots being observed as the storms were occurring. Cape was already over 1,000 joules per kilogram by mid-afternoon, meaning there was plenty of potential energy for supercell thunderstorms to take advantage of. Bubbling cumulus clouds were forming and heading into southwestern Arkansas around 1:30 to 2 p.m. Central Standard Time. However, no substantial storms initially formed due to the cap in place. The SPC was keeping a close eye on the cumulus clouds that were forming in the area, with Thompson explaining what he observed from what was forming in the area.
Well, we had a mesoscale discussion that I want to say was around 2:30 that afternoon, talking about, a little bit of agitated cumulus, and, these weren't thunderstorms. It was just bubbling cumulus clouds. It was related to that speed max I mentioned, and it was headed towards southwest Arkansas. So we did a mesoscale discussion, and about 30 minutes later, I issued the first tornado watch. There were no thunderstorms when I issued that watch, and that included Mayfield. So that's a little unusual to issue a watch, and there's no lightning flashes, there's no thunderstorms anywhere in there. But we said, hey, we think this is where it's going to come out of this. We just don't know if it's going to be the next hour or if it's going to be 2 or 3 hours. So I issued that at 3. I left at 4 o'clock Central Time. There were no warnings and no severe storms anywhere in the country that I remember when I left. There were a few lightning flashes and, a few weak thunderstorms were the early stages. It was somewhere near or just southwest of Little Rock, Arkansas when I left. That's what one of those ended up becoming the Mayfield storm. It was a couple of lightning strikes and a few small echoes when I walked out the door. And then that was it. So there was no severe weather going on. It was all to come. So the question was, how quickly would that ramp up? And, the time I left, I thought, well, it should be the next couple hours, but we'll see. So I walk out the door, not much is going on there.
The initial tornado.
Yeah, the initial tornado watch actually did include Graves County, Kentucky, which is where Mayfield is located. But the storms hadn't formed yet, and when they did, they were still southwest of Little Rock, between Hot Spring and Little Rock.
Watch, which included most of Arkansas, southeastern Missouri, southern Illinois, southwestern Indiana, western Kentucky, western Tennessee, and northwestern Mississippi, was not a particularly dangerous situation watch. However, the tornado watch was as close to being a PDS watch without being one. The tornado probabilities consisted of a 90% chance of 2 or more tornadoes, with the probability of 1 or more strong tornadoes being 70%. Storms began to formally develop in south central Arkansas around 2:30 p.m. Central Standard Time. An hour later, storms began to initiate in portions of Missouri, and from 5 to 5:30 p.m., a line of storms began to form in Oklahoma along the cold front. More tornado watches were issued shortly after 5 p.m., including another high-end tornado watch for portions of Missouri and Illinois. More tornado watches would be issued throughout the night as the storm system moved east. Between 5 to 6 p.m. Central Standard Time, the cap was beginning to break in Arkansas. One of the cells that formed in the early mid-afternoon near Arkadelphia, Arkansas, had been struggling to produce anything significant. However, shortly after 5:30 p.m., the cell began showing signs of rotation. The supercell became tornado-warned just after 5:50 p.m. and would drop a few weak tornadoes, marking the beginning of the tornado outbreak. What wasn't known at the time was that this supercell would be responsible for the 2 EF4 tornadoes that night, and one of the most infamous tornadoes in world history. After producing a number of small, weak tornadoes in portions of central Arkansas, the Quad State Supercell produced a tornado east-southeast of Jonesboro, Arkansas. The tornado initially damaged some storage buildings and outbuildings before gradually strengthening as it moved northeast. The tornado weakened slightly before quickly re-intensifying and producing EF3 damage as it moved into Monette, Arkansas. The northern and northwestern portions of the town were struck by the tornado, with home and retail facilities having their roofs partially or completely removed, and the roof of a nursing home partially collapsed in the town, killing 1 and injuring 5. The tornado maintained its strength as it continued into Mississippi County, striking the northern portions of Leachville, Arkansas, damaging or destroying numerous structures as it moved throughout the county. A store along Highway 77 had its anchors pulled out from the concrete foundation. The tornado then moved into Dunklin County, Missouri, producing severe damage as it moved through the area. The tornado overturned and tossed several vehicles and a boat. Trees were debarked, and 5 metal electric transmission line towers at the top portion of the towers collapsed, with 1 transmission tower collapsing entirely. The tornado intensified further as it moved into Pemiscot County and began producing EF4 damage, destroying 2 homes, damaging another house, and blowing numerous vehicles off roads as it moved through. The tornado clipped in between the Lake County, Tennessee and Pemiscot County, Missouri border before going through Lake County, Tennessee once more. The tornado continued to produce EF4 damage as it moved southwest of Winburg, Tennessee, debarking several trees, with homes and shops suffering substantial damage to the north of the town. The tornado approached Reelfoot Lake, significantly damaging a hotel, convenience store, and other camping facilities in the area.
That is really, really close to the Kentucky, Tennessee, and Illinois, Missouri state lines. Illinois doesn't exactly touch Tennessee, but I think that is like the closest I have ever seen a storm get to Illinois. I've heard Illinois storms warned for Alexander, Massac, and Pope counties in Illinois that have crossed Reelfoot Lake State Park. So, yeah, this was getting bad.
The tornado shrunk and weakened as it moved into Obion County, still producing damage to multiple buildings in Samsburg, Tennessee. The tornado continued moving northeast before lifting west of Treese Road. This tornado passed through 3 different states in roughly an hour and a half, with a path length of just over 81 miles, a peak width of over a mile wide, and peak winds of 170 miles per hour. The tornado caused an estimated $13.5 million in damages total, killing 8 and injuring 14. As the tornado was ravaging through Arkansas, Missouri, and Tennessee, NWS Paducah knew that this was the storm of the night.
Oh, well, as soon as we saw the supercell in Arkansas, you can ask any one of the forecasters working that night, well before it even got into the Missouri Blue Hill, every single one of them knew that that was going to be the storm. There was no doubt. And we had started tweeting out about that time to say, those of you in far west Kentucky, far southwest Kentucky, be ready. This could be potentially horrible. So we knew just by virtue of the storm, the environment was moving into, we knew this was it. So you just as meteorologists, you just know. And again, we are constantly monitoring data coming in from various different sources, and everything was pointing toward that this thing's not stopping, and it's got nothing to do but to increase in intensity.
As the initial violent tornado in Arkansas, Missouri, and Tennessee was occurring, 2 other notable tornadoes occurred in Missouri and Illinois. At 7:35 p.m. CST, a tornado touched down in southwestern St. Charles County, initially only producing minor damage. However, the tornado quickly strengthened as it approached Highway F, producing high-end EF3 damage. 2 homes were completely destroyed along Highway F through Highway 94, with one of the houses being swept clean of its foundation, although the house was 110 years old and had no anchoring to the foundation. The
Still.
house next to it was swept clean to the subfloor, which was still anchored to the foundation.
That was the first tornado in the St. Louis Metro. That tornado right there in St. Charles County. Yeah, it was ugly.
The tornado weakened substantially as it moved through portions of St. Louis County, back into St. Charles County, and then back into St. Louis County again, producing mostly tree damage before lifting at 8:01 p.m. An interesting fact about this tornado is that the tornado got extremely close to hitting the office of NWS St. Louis, leading to the office making the decision to take shelter and go into backup mode, with NWS Kansas City, Missouri, taking over warning responsibility. This was the 3rd time NWS St. Louis had to go into backup mode in recorded history. The tornado traveled just under 25 miles total and had peak winds of 150 miles per hour and a peak width of 150 yards. The tornado caused $3.4 million in damages, killing 1 and injuring 2. At 8:27 p.m. Central Standard Time, a tornado touched down on the south side of I-270, downing several highway signs and bending a light pole. The tornado moved northeast and rapidly intensified as it crossed I-255, striking an Amazon warehouse southwest of Edwardsville, Illinois. The west-facing walls of the warehouse collapsed inward, and what followed was numerous structural failures as the tornado moved through the complex. More walls collapsed, and a large segment of the roof of the warehouse was lost. Cars in the rear of the building were strewn eastward, and power lines and several large high-tension towers were destroyed. The tornado quickly weakened after striking the Amazon warehouse, destroying mobile homes and causing mostly minor tree and house damage before lifting west of Butler Boulevard at 8:35 p.m. The tornado was on the ground for an extremely short period of time, being on the ground for just 8 minutes, only traveling a little over 4 miles with a peak width of 300 yards. Despite that, the tornado caused $5 million in damages, killing 6 and injuring 1. All of the casualties and injuries occurred at the Amazon warehouse.
And that Amazon warehouse will come up again as a controversial moment in this story again. Basically, I'll just summarize it here, though. So, what many of the employees remember from this was Amazon's person that they had on duty that day was not very well trained in safety. In fact, instead of allowing them to take shelter, he threatened them with firing if they were to leave the building and take shelter. And that included a driver who said that if she wasn't, that basically said, that the employer was saying, if you don't finish your route, ma'am, we're going to fire you. Well, you can see how that ended up. It ended up that 6 people died because of that. And a similar situation actually occurred in Mayfield, Kentucky. So, yeah, you'll see that. You'll hear the rest of that when he gets to the controversies.
The Edwardsville, Illinois tornado and the first violent tornado from the Quad State supercell lifted at roughly the same time, and all focus was given to the Quad State supercell. It was extremely difficult to tell on radar at the time, but the Quad State supercell initially struggled to produce and keep another tornado on the ground, producing 3 weak, short-lived tornadoes in the span of only 20 minutes. However, at 8:54 p.m. Central Standard Time, the Quad State supercell produced its 9th tornado. A tornado that would go down in the record books and would become one of the most infamous tornadoes ever observed on this planet. The only tornado from the outbreak that those in the general public know about in detail. That being the Western Kentucky tornado. At 8:54 p.m. Central Standard Time, well into the overnight hours for the area, the most powerful tornado of the outbreak touched down in northern Obion County, Tennessee, producing roof damage and uprooting trees in the area. The tornado crossed the Kentucky-Tennessee state line into Fulton County, Kentucky, and the tornado quickly became violent with winds of 170 miles per hour, widening to over a mile across as it aimed straight for the small community of Casey, Kentucky. Several well-built and bolted structures, such as a few businesses and homes, were leveled or swept off their foundations. The tornado destroyed several outbuildings and snapped and debarked trees. The tornado moved through northern Fulton County, causing extreme damage as a 280-foot radio tower was snapped off and tossed a short distance. In Fulton County, 1 passed away, with 5 others sustaining injuries. The tornado widened to 1.5 miles wide as it traveled into Hickman County, with numerous wooden towers carrying electrical transmission lines collapsing. Excessive ground scouring up to 1 foot deep alongside a trench being produced from the tornado was noted in the area. Bear in mind that everything about this tornado was hidden by the dark of night. Anyone in its path would only be able to see it if lightning happened to light up, or by the tornado producing power flashes as it continued on its path of absolute devastation. The tornado weakened slightly as it crossed the Hickman-Graves County line, injuring 5 in Hickman County. Despite the initial weakening, the cell's radar signature was intense. Debris was being tossed up to 20,000 feet in the atmosphere, even though the tornado was only traveling across mostly rural areas. The tornado traveled into Graves County, shrinking in size but still over 1 mile wide as it traversed the county. The tornado got close to the small community of Baltimore, Kentucky, with a farmstead in between Baltimore and Hollifield being destroyed and a silo being tossed into a field 200 to 500 yards away, with another silo being unable to be located. The tornado then made a beeline for Mayfield, Kentucky, a city with a population of roughly 10,000. NWS Paducah was monitoring the storm carefully, and then, as the tornado was about to enter the city limits of Mayfield, NWS Paducah issued a tornado emergency for the city of Mayfield at 9:26 p.m. The first time the office had ever issued a tornado emergency. I asked Christine Welgos about what led to the issuance of the tornado emergency, and she gave me some insight as to what was happening.
As soon as the storm crossed the border into Kentucky, of course, as you know, the tornado actually touched down just across the border into Tennessee. And as soon as it touched down in Tennessee and then quickly crossed the border into Kentucky, it immediately became violent and hit the town of Casey, Kentucky. I was down there doing surveys. I mean, I was out doing surveys for many days and many weeks, but the damage in Casey was extreme. And so this thing developed and became very violent very quickly. And so there are certain things that you can see on radar that tells you the caliber of the event you're dealing with, some of the reports we were getting. And so the warning forecaster had in his mind that, be prepared. I might need to issue this tornado emergency. So it was back in Fulton, Hickman counties that, he was already thinking about it. And then, pulled the trigger when, it was in Mayfield. And that, a tornado emergency is basically very rarely used. It is basically our last ditch effort to stand up and shout and say, hey, this is horrible. This is a life-threatening situation. This is not just a little EF0 tornado. This is a violent, half mile to mile wide tornado. And so, that there's a lot that goes on. I can't, you can't get into the mind of that warning forecaster, but that's just a small glimpse of all the decisions that a warning forecaster has to make with all of the data that is being thrown at him or her. You have no idea what it's like to be sitting in that hot seat. So that is just a very small percentage of a little bit of the thought process behind that.
Just around 9:30 p.m. Central Standard Time, the tornado entered the city of Mayfield, first striking a candle factory, demolishing the building with at least 9 people dying as the walls came crumbling down around them. The tornado then moved into downtown Mayfield, causing extreme damage in the city, with winds being estimated to have been 190 miles per hour. The worst damage was in the business district, where numerous businesses collapsed. Power lines were down all across the city, and Mayfield's emergency management services lost the ability to use radio communications. At least 1,500 structures were damaged or destroyed, and the Red Cross stated that an estimated 730 dwellings became uninhabitable. The tornado permanently scarred the heart of Mayfield in a span of roughly 2 minutes. The tornado moved out of Mayfield, continuing to cause significant damage. All the while, NWS Paducah issued tornado emergency after tornado emergency for numerous towns and cities in a desperate attempt to convince those to take shelter as soon as humanly possible. In Graves County alone, 24 fatalities occurred, with 210 sustaining injuries from the tornado. The tornado moved into Marshall County, weakening slightly as it moved north of Benton, Kentucky. The tornado widened out again to 1.5 miles wide in the county, severely damaging multiple homes and leveling others as a high-end EF4 tornado. A small cell initiated ahead of the Quad State supercell, but was quickly absorbed into the Quad State cell. The absorption of the outside cell only enhanced the tornado's intensity as it struck Cambridge shores, where numerous homes were leveled and several others sustaining light to moderate damage. Vehicles were tossed into Kentucky Lake as the tornado moved through with winds of 170 miles per hour. In Marshall County, 1 passed away and 54 were injured. The tornado crossed over Kentucky Lake and into Lyon County, Kentucky, where an ominous photo was taken of the tornado being illuminated by lightning. While the tornado weakened to a high-end EF3, the tornado caused extreme tree damage as it crossed Trace Highway, with all trees within the center of the tornado's path being completely destroyed. The tornado continued to cause significant devastation as it moved towards the Lyon-Caldwell County line. In Lyon County, 1 passed away and 5 were injured. The tornado moved into Caldwell County, intensifying again to an EF4 tornado with winds of 180 miles per hour. The tornado crossing the Princeton Golf and Country Club, with walls of nearby homes collapsing. The tornado then moved southwest of Princeton, Kentucky, destroying large sections of the University of Kentucky Research and Education Center, which had issues regarding the construction of the building. The tornado continued to damage homes along US Highway 62 before taking an eastward shift in its track, before shifting back towards the northeast as it crossed into Hopkins County and into Dawson Springs. In Caldwell County, 4 passed away and 11 were injured. At roughly 10:30 p.m. Central Standard Time, as the tornado was moving into Hopkins County, NWS Paducah lost power.
So the commercial power went out. And so normally, when commercial power goes out to our building, we have a transfer switch that transfers we go to battery and then we go to a generator. Well, the transfer switch did not work for whatever reason. So the first thing you do is you call in your electronics technicians. So they came in right away within minutes, coming in, and we actually even tried to get the generator running. So they even brought in like huge diesel tow trucks to try to jumpstart the batteries to see if that would help start the generator. Nothing was working. And so, we were running on batteries for a little while. Once commercial power went off, the batteries will afford us some time. So that time is used to try to figure out how can we get working on the generator. And in that time frame, NWS Springfield was well aware of what was going on, was ready to take over. All we had to do was snap our fingers and they took over for us. And so we just, at a certain point, you can't let the batteries go down to nothing because it can damage a lot of core components here at the office. So decision was made to say, okay, we're going to go to backup, and whatever time that was, 10 o'clock or whatever, Springfield backed us up, seamlessly put off the rest of the warnings as the tornadic storm continued to go across the rest of West Kentucky.
Eventually, NWS Paducah got power back, but the tornado was still raging on as it moved into Hopkins County. In Hopkins County, the tornado was thought to have reached its peak intensity. The tornado hit Dawson Springs at 10:33 p.m., causing catastrophic damage to the town. 2/3 of the city's homes were destroyed, narrowly missing the business district of the town. A 2-story apartment building was completely destroyed, and most areas saw the complete loss of roofs and exterior walls. Nearby, half a dozen other smaller homes and businesses were demolished. The tornado then crossed Interstate 69, with a wide path of near total tree destruction across the interstate. The tornado moved through a mostly wooded area until it reached the small community of Barnsley, Kentucky. Several houses were demolished, and a train was derailed with a 55-foot tanker being thrown 20 yards away from the tracks.
Damn. That's insanity. And a 55-foot tanker, that's probably several tons easily. And the fact that wind was able to suck it up and fling it 20 yards away, yeesh. That's scary.
The tornado continued moving through mostly forest land, causing severe tree damage as it moved into Muhlenberg County. In Hopkins County, 15 passed away and 200 sustained injuries. The tornado took direct aim at the town of Bremen, where the tornado's winds once again reached its peak of 190 miles per hour in the area. Over 100 structures were damaged or destroyed, with 84 being completely destroyed or uninhabitable. Houses were completely swept off their foundations, although most were poorly constructed. A 2-story home on the north side of Bremen was completely gone. The tornado continued moving through Muhlenberg County, causing a cluster of damage near Mormon, Kentucky, before crossing into Ohio County. In Muhlenberg County, 11 passed away and 25 were injured. As the tornado moved into Ohio County, the tornado was gradually weakening from this point onward, as convection began to overcrowd the inflow region of the cell, interfering with the tornado's rotation. Severe damage was still observed in between Hartford and Beta, with several well-constructed buildings being destroyed. A well-built home had most of its walls collapsed in Utley Drive as it passed, with the tornado producing EF3 damage in the county. No injuries or fatalities were reported out of Ohio County. The tornado kept weakening, becoming more narrow in structure as it moved through Breckinridge County and Grayson County, producing EF2 to EF1 damage, mostly to trees in the area. The tornado then moved into Grayson County for the final time, causing minor damage before finally lifting at 11:48 p.m. Central Standard Time on December 10th. The Western Kentucky tornado is infamous for the sheer level of consistency regarding the damage observed, with most of the damage being rated EF4 in the counties it tracked through. The Western Kentucky tornado might only be known for what it did in Mayfield, since it was the city with the highest population that got hit, but the destruction it brought is something that was observed across multiple areas in its path. The tornado was on the ground for nearly 3 hours with a path length of 165.6 miles.
Yeah, it tracked over 165.6 miles in, according to my calculations, 2 hours and 54 minutes. Yikes. Yikes. That's insanity. That is insanity. It's not exactly, I don't exactly know what the average storm movement on that was, but I can at least assure you that it was at least 60 miles an hour, if not much higher than that. In fact, I wouldn't be surprised if it was at least 70 miles an hour.
The longest continuous tornado path observed in Kentucky, and the longest tracking tornado since 1975, with a peak width of 1.5 miles wide. While damages are not finalized for the tornado, the Western Kentucky tornado's damages are easily in the billions, with 57 people perishing to the tornado and 515 sustaining injuries. Richard Thompson, while not there at the SPC covering the storms, was periodically checking out the event on radar. I asked him what he observed from the outbreak, specifically from the Quad State Supercell, and this is what he said.
Yeah, no, I got home well before the tornado started. So if I remember correctly, the first tornadoes were sometime around 7 o'clock Central Time in Northeast Arkansas is about where it starts. Somewhere between 7 and 8 Central Time. So near or just after sunset is when the tornado started. The first warning started with that supercell, maybe 6:30. So it was close to just about sunset is when that started. By that point, I was already home. I had radar running in the background. And, I'm a professional forecaster, but I'm a weather weenie. So I have always been involved with the weather. So, anytime I have like a high-end tornado watch and I've got a moderate risk, I'm going to watch how that plays out when I'm go home. So I had the opportunity to look at it, and I was checking in periodically. I remember checking around 6 and I said, okay, it hasn't gotten going yet. I said, there's a storm that looks like it might want to be a supercell, but it's still a little bit skeletal, and there's no warnings. There've been no reports. I thought, well, at that point, there's still the small possibility that it dissipates. So, it's not terribly common any time of year to follow initial thunderstorms and for it to take 3 to 4 hours before the severe weather starts. That's what that day did. Most of the time when that occurs, guess what happens with those initial storms? They die. And there was the small chance that it's like, wow, if it doesn't get going during the tail end of daytime heating, it might just dissipate. We might wait for overnight storms and the whole threat plays out differently. So I glanced around 6, nothing was going on. And I thought, boy, I hope this isn't one of those cases where it dissipates. I said that would be, because now we've got a false alarm. I've got a false alarm tornado watch. I've got a false alarm upgrade. And I don't want that, but I'm not, you want your forecast to be accurate so that next time people will trust you, but you don't want there to be a devastating severe weather event. So it's a tough place to be in. You don't want your forecast to be wrong, but you don't want everything to be destroyed. And so I'm still just trying to figure out how my forecast is going to play out. So I was checking back in probably every 20, 30 minutes the rest of the evening. So I was well aware of the progress of the Mayfield storm. And I looked at tens of thousands of supercells on radar. So I was watching that and kind of analyzing the storm and the environment on my own at home, because it became pretty apparent by about 8 o'clock that this was not a normal scenario. And so, the more of an outlier it started to look like, it's like, wow, really the worst case scenario is playing out. So it's, that it just piqued my curiosity. And I was looking at it all the way up until I went to sleep, probably 11 p.m. off and on. It was kind of hard to get to sleep because then I know that we've had a devastating tornado. We don't know the details, but it's like, okay, this was bad. And I got to go to work the next morning, and, I can't focus too much on what happened the day before because I got to make the forecast for the next day. So it's an interesting challenge trying to keep all that straight, not, to where you try to be professional about it, but still be interested in just looking at the raw power of the atmosphere, and appreciating all of the crazy stuff the atmosphere is capable of producing. So it makes for, that's one of the things I love about working at SPC. I kind of get the best of both worlds. I get to try to help with the forecast products, and I always get to look at what I consider to be the most interesting weather, since we follow everything across the whole country. And so, yeah, I was well aware of what was going on that evening with the Mayfield storm.
People knew that the worst case scenario had just occurred, just not knowing to what degree. But the tornado outbreak was far from over at this point. Most people covering this outbreak would stop here. However, this outbreak was so much more than the Western Kentucky tornado, and it is worth taking a look at the other major tornadoes that formed after the Western Kentucky tornado touched down. A separate supercell that formed over Mississippi County, Arkansas, produced a significant long-track tornado at 10:38 p.m. over New Bern, Tennessee. The tornado already began producing heavy damage, producing EF2 damage with a convenience store suffering heavy damage, and an elementary school and an auto shop suffering roof damage. The tornado produced mainly tree damage as it moved into Gibson County, Tennessee, uprooting and snapping more trees and causing significant roof damage to many houses in the rural parts of the county. As it approached the city of Kenton, Tennessee, the tornado intensified again, causing significant damage to numerous homes with winds of 140 miles per hour. The tornado weakened slightly as it moved through Obion County, then back into Gibson County before moving into Weakley County, Tennessee. The tornado uprooted and snapped many trees as it passed north of Sharon, Tennessee. The tornado strengthened as it approached Dresden, causing significant damage to homes along Highway 89, then reaching its peak intensity as a high-end EF3 with winds of 160 miles per hour in Dresden, Tennessee. Numerous homes and businesses were destroyed in Dresden, with 187 homes in the county being damaged, with 100 of those being complete losses. The tornado moved into Henry County, weakening slightly but still producing EF3 damage as the tornado moved through, snapping and uprooting trees and severely damaging mobile homes near Kentucky Lake. The tornado crossed into Callaway County, Kentucky before crossing into Stewart County, Tennessee, producing EF2 damage as it damaged thousands of trees, and a well-built brick home had its roof and second story torn off from the building. The tornado then moved into Christian County, Kentucky, producing EF2 damage as it moved just southwest of downtown Lafayette. Between Lafayette and I-24, several homes were destroyed, with many suffering complete roof destruction, and one house was moved from its foundation. The tornado weakened further, producing EF1 damage in Todd County, Kentucky, blowing roofs off of barns, causing minor to moderate roof damages to houses and outbuildings, and causing mostly tree damage. The tornado lifted 4 miles west of Elkton, Kentucky. The Dresden tornado traveled a total of 125 miles across western Tennessee and into western Kentucky, the second longest path from the tornadoes from the December 10th outbreak, with a peak width of just over a mile wide and peak winds of 160 miles per hour. The tornado caused $11 million in damages and injured 34. The supercell responsible for the Dresden tornado quickly cycled and produced another significant tornado in Logan County, Kentucky, touching down in the county at 12:47 a.m. Central Standard Time. The tornado almost immediately began producing EF3 damage, with a width of 3/4 of a mile. A large dairy farm was completely destroyed, and multiple other structures suffered damage from the tornado. The tornado began to weaken as it moved over US 431, impacting structures with EF1 winds. The tornado moved into Warren County, dissipating at 1:14 a.m. Central Standard Time. The tornado was on the ground for roughly 30 minutes with a peak width of 4/5 of a mile, having peak winds of 140 miles per hour and injuring 1. The same supercell that was responsible for the Dresden and Logan County tornado would produce another significant tornado impacting Bowling Green, Kentucky. The tornado initially touched down at 1:09 a.m. Central Standard Time in southwestern Warren County. The tornado initially produced EF1 tree damage before gradually increasing in strength as it produced major damage to old barns in the area. A National Weather Service drone showed a main funnel within a larger funnel, which accounted for the ground scouring in the area. The tornado intensified to EF2 strength, with the narrow funnel striking a well-built home, only leaving the interior bathroom and hallway standing. The tornado continued moving to the northeast, and the tornado entered the western portions of Bowling Green, Kentucky, producing EF3 damage, where multiple homes were destroyed and left only with interior walls standing. The tornado then crossed I-165 as an EF3 tornado, with the tornado causing a massive power failure in Bowling Green. The tornado struck the Creekwood subdivision next, with numerous homes being completely destroyed from the tornado. Numerous portions of the city witnessed significant damage, with damage ranging from EF1 to high-end EF3. The tornado reached peak intensity as it struck an industrial park near US 68, destroying multiple large industrial buildings at a high-end EF3 strength. The tornado weakened after striking the park, moving through and causing significant damage to numerous structures outside of Bowling Green, Kentucky, before lifting just after crossing into Edmonson County. The tornado itself caused excessive damage in the Bowling Green area, with the tornado originally being rated 170 miles per hour as an EF4 before being downgraded to a 165 EF3. Regardless, the tornado traveled nearly 26 miles with a peak width of a quarter of a mile, peak winds of 165 miles per hour, with 16 people passing away and 63 being injured. The last EF3 tornado from the outbreak touched down at 3:27 a.m. Eastern Standard Time in Taylor County, Kentucky, originally producing EF1 damage to farm buildings and trees. The tornado continued moving northeast and intensified as it moved towards Quinsonberry Road. While the tornado was there, the tornado destroyed several mobile homes with a damage width of 200 to 300 yards. The tornado impacted Saloma Road, where more structures had significant damage. One house had the entire second floor removed. Numerous trees were snapped or uprooted. The tornado then impacted Sanders Road, where the tornado peaked in intensity, producing EF3 damage with homes being left with no walls standing, and swaths of forest over a quarter of a mile wide were snapped or uprooted. The tornado began to weaken as it moved into Marion County, producing EF1 to EF2 damage in southern Marion County before lifting at 3:36 a.m. The tornado traveled a total of 14.5 miles with a maximum width of a quarter of a mile wide, producing EF3 damage. The tornado caused 1 death and injured 31. As the outbreak continued into the early morning of the 11th, the squall line that formed in Oklahoma and Arkansas began to absorb the supercell thunderstorms ahead of it. Some of the thunderstorms ahead of the line grew upscale and became another line of storms. At this point, the main threat of the storms came from the strong straight-line winds from the squall line and tornadoes from embedded supercells in the line. On December 11th, a Day 1 slight risk was issued for the rest of the squall line moving through Ohio southward, and a marginal risk was issued for portions of the Northeast. Hail was not very prevalent with the system, with the largest hail being 2 inches in diameter in Bogota, Texas. Winds, on the other hand, were widespread, with the highest wind gusts being 85 miles per hour in Tremont, Illinois, with hundreds of thousands of people losing power across Illinois, Michigan, Indiana, Wisconsin, and New York due to the winds. The winter storm associated with the storm complex was also historic for reasons on its own. Portions of the western United States saw the storm drop a total of 3 feet in the mountains. In South Dakota, no travel alerts were issued for several highways in Sioux Falls, with numerous school districts canceling classes. In Minnesota, the Twin Cities saw 21 inches of snowfall. The snowstorm was the heaviest in the area since the blizzard in April of 2018. However, during the morning hours of December 11th, news stations across the United States and the National Weather Service started traveling to the areas where the tornadoes occurred. Of those doing damage surveys, Christine Welgos went out to Mayfield to do surveys, and I'll let her explain what she witnessed.
When we drove south into Mayfield, there's kind of a hill before you get into downtown Mayfield. When you cross over that hill and you get a glimpse of downtown Mayfield, it was like, a nuclear bomb went off. And, I've been doing this for 22 years. I've seen a lot of damage, right? I've seen a lot of tornado damage. I've been through a lot. Been through the Evansville tornado. But the actual caliber of the event, I think, when you look, and from as far as the eye can see, when you're talking about a mile wide of extensive damage, that's really hard for most people to comprehend. And so you're seeing it on the ground, and all you're seeing from one, horizon to horizon, all you see is damage. there's no word to really describe that. It's inconceivable. You know, how many lives were impacted, whether you lost a shingle off your roof or whether your whole house was gone, you're impacted. Whether you were had any damage at all, those are your neighbors, those are your friends, those are your family members, your people you go to church with. You know, Kentucky is a very tight knit. There's a lot of tight knit communities here, and so you know, and that's what impacted us. We live here. These are our people that we serve, and so it really impacted the office. Whether you worked the event, whether you went and saw the damage, whether you were working the midnight shift and didn't get to experience any of it. It impacts every single one of us in a different way. So there really are no words to describe it, Grace, and it's not something that I hope to ever see again in my lifetime.
And good evening tonight from Kentucky, the epicenter of what authorities have now confirmed is the nation's deadliest tornado outbreak in more than a decade.
Tonight from Mayfield, Kentucky, the deadliest tornado outbreak in years. The loss of life and property absolutely devastating.
So when the sun started coming up this morning, it was like matchsticks. Our whole town looks just like matchsticks lying around.
You know, the scope and scale of this destruction is almost beyond belief. When you look around here, it's just almost beyond belief. These tornadoes devoured everything in their path.
As daylight shined across the eastern United States, and as bitter winter air came into the region, clearer images were coming out from where the tornadoes tracked, and the photos confirmed that the worst-case scenario had just occurred. Numerous significant to violent tornadoes had raged overnight across Arkansas, Tennessee, Missouri, Illinois, and Kentucky. Quickly, states of emergencies were being issued in multiple states for the outbreak. Specifically in Kentucky, President Joe Biden signed federal disaster declarations for Kentucky, Tennessee, and Illinois as a result of the tornadoes from the outbreak. The damage from the December 10th through the 11th outbreak was the worst damage observed from a tornado outbreak since 2011, and consistently violent in nature. From the first EF4 tornado from the quad-state supercell, forest after forest had swaths of trees completely debarked from the tornado's intensity, and houses were left as piles of debris. Near Defiance, Missouri, numerous houses suffered significant damage. A 110-year-old home swept off its foundation. A single-family ranch home suffered EF3 damage, with a new house nearby having major damage. Near Edwardsville, Illinois, the Amazon warehouse was severely damaged, with a majority of the building being completely exposed to the outside. Dresden, Tennessee saw major damage. A metal building completely collapsed, and multiple businesses in downtown Dresden were severely damaged. In Logan County, Kentucky, a dairy farm was completely destroyed. The top floor of a home off Milton Sharp Road was gone. Numerous mobile homes were destroyed, and the spire of the Chandler's Chapel Methodist Church was ripped from the building. Drone shots in Warren County showed the utter devastation across the county, specifically in Bowling Green. Neighborhood after neighborhood suffered unimaginable destruction with debris scattered about. Numerous businesses sustained severe damage, with some buildings collapsing entirely. United States Senator Mitch McConnell, who lived through the 1974 super outbreak in Louisville, Kentucky, visited Bowling Green a couple days after the tornado hit. As he witnessed the damage for the first time, he said,
"This is the worst devastation I've seen since 1974 when a similar tornado hit Louisville and Jefferson County."
A statement that supports the comparison that the damage observed in the state from the December 10th through the 11th outbreak was the worst seen since the 1974 super outbreak for the state of Kentucky. But the main focus of the damage was, undoubtedly, with the Western Kentucky tornado.
Yeah, honestly, this thing was not a good situation. It really, the worst case scenario had played out. It was awful. Just awful. Now, I will say a lot of media outlets prematurely claimed that the quad state supercell had actually dropped what now is debunked, but a lot of media outlets claimed was the quad state tornado from Arkansas, Missouri, Tennessee, and Kentucky. Now, if that would have been the case, that would have been the longest tornado track since the tri-state twister of 1925. However, again, it was later confirmed that those tracks were two separate tornadoes instead of one giant tornado. It was two separate twisters that lifted. One lifted in Obion County, Tennessee. The next one touched down in Obion County, Tennessee.
In Casey, Kentucky, most of the community was destroyed from the tornado. Houses were left with just a pile of debris on their foundation. Some houses were swept clean off of their foundations, and extreme tree damage was prevalent around the community. Houses were slabbed in Cambridge Shores, including large multi-story buildings and a well-built home anchored to the ground. Numerous trees were destroyed in the area as well, and vegetation damage was extreme and widespread. The Princeton Country Club area saw massive devastation, with debris being the only thing visible in the surrounding area, with the University of Kentucky Research Building being the site of the worst damage in the area, with only some of the interior walls and exterior walls being left intact. Excessive damage was observed in Dawson Springs, with many houses being completely uninhabitable. Extreme tree damage. A 2-story apartment complex was left with only its foundation. Factories were leveled, and aerial shots showcased the level of destruction in the small community. President Biden stated regarding the damage in both Mayfield and Dawson Springs,
The scope and scale of this destruction is almost beyond belief. When you look around here, it's just almost beyond belief. These tornadoes devoured everything in their path.
Numerous homes in Barnsley were destroyed, left only with their foundations, one of those being a well-built block home. Bremen saw extreme damage as well, with house after house being slabbed off of their foundation. There was nothing but absolute destruction in Bremen. Severe damage was still observed afterwards, but not to the extent as in the areas hit previously from the tornado. But most of the focus of the damage from the outbreak was in Mayfield, Kentucky. The tornado, in the span of 2 minutes, left the city of Mayfield completely unrecognizable. The candle factory was flattened to a level of destruction similar to the Gene factory from the Hackleburg tornado from the 2011 super outbreak. The fire and police departments obliterated. Power lines brought down across the area, dampening emergency communications between the Mayfield Emergency Management and other agencies. 3 churches gone. Numerous houses swept off of their foundations or left as piles of rubble. Cars were thrown and mangled together. The level of devastation observed in Mayfield and all across the Ohio River Valley and Mississippi Valley was on a scale that had not been seen in over a decade. People across the nation were fearing deaths from this outbreak to be in the triple digits. And to be fair, with the level of devastation observed across the Mississippi and Ohio River valleys, those thoughts were reasonable. However, many people heeded the warnings and were paying attention to the weather, likely preventing the death toll from being much, much worse. In total, 672 people were injured from the outbreak, and 93 people died. 90 people from the tornadoes, with 3 people suffering non-tornadic deaths. Of those who perished, 57 of them were from the Western Kentucky tornado, making the Western Kentucky tornado the deadliest tornado since the Joplin tornado from 2011. The reason as to why the Western Kentucky tornado's death total was so high was because the tornado struck town after town after town. The outbreak quickly became the deadliest outbreak in the month of December, and in general since 2011. While a final damage total isn't finalized, the damage from the outbreak is estimated to range from $3.1 to $5.3 billion, with most of the suspected damage being linked to the Western Kentucky tornado. 71 tornadoes were produced during the outbreak across multiple states, with 1 EFU, 17 EF0s, 30 EF1s, 15 EF2s, 6 EF3s, and 2 EF4s. With such a high tornado count, the December 10th tornado outbreak broke the record for the largest tornado outbreak observed in the month of December. A record that was held by the outbreak for less than 5 days because of the December derecho that happened on December 15th, a topic that I have previously covered in a video. And the worst part of it all this devastation, all of it occurred within 2 weeks of Christmas. The most joyful part of the year for numerous Americans and for those around the world. Many people in these areas were preparing for the holidays, excited to spread the holiday cheer with friends, family, and their communities, and yet, in the blink of an eye, everything these people had, everything these people worked toward, everything these people wanted to bring to the world, almost all of it was taken away 2 weeks before Christmas. And yet, it is often during the worst of times after natural disasters where hundreds of thousands up to millions of people have had everything taken away when the best of humanity is showcased. People across the country began donating to local charities to go to the victims of the tornadoes. Local churches in Mayfield held services on the following Sunday, even with their churches being completely destroyed. People in Mayfield and the towns affected came together to help clean up the cities and help local officials with the recovery effort. People from around the state of Kentucky to people outside of the state were making their way to Mayfield, were making their way to Bremen, were making their way to Dawson Springs, making their way to Bowling Green, all in an effort to help those who had everything taken away from them by no fault of their own. Jim Finch, who lived half an hour away from Mayfield, drove to the city with a grill and a truckload of food, parked right in the middle of Mayfield, and started cooking for the residents there. As to why he came to Mayfield to cook there, he said,
I know they don't have no electricity, so that means they don't have no restaurants or no running water, so I just figure I'd do what I can do. Show up with some food and some water.
Just across the street, a church was hosting a service as Finch was making food. Truly, the best of humanity observed after the event. Despite the death and destruction observed across the region, a glimmer of hope as people began rebuilding and doing their best to help those who were left with nothing. The recovery efforts are still far from over, with numerous people across the state still arguing with insurance companies, and people have yet to receive their payments from FEMA. The pain the victims of the outbreak will experience will last for a lifetime, and is something that I, nor those who were not affected by the outbreak, will ever truly understand, as much as people would want to. Before I asked for closing statements about the outbreak from both Richard Thompson and Christine Welgos, I wanted their thoughts on how their respective agencies performed that day, and this is what they told me.
Ironically enough, we were discussing that today. I don't remember how we got on the subject. This was it was in the morning, the day shift. We were just talking about, and occasionally we'll review events, and we were talking about that one. And or that event came up as part of what we were talking about. I think that if I were to have to characterize SBC's overall performance, again, I'm pretty hard on myself, and by extension, I expect a lot from the Storm Prediction Center. I expect us to do well. Looking back on how that played out and what we knew at the time, the information we had available before it happened, and a reasonable assessment of the uncertainty. It's always easy to look back and say, well, of course you should have known there was going to be a 160-mile track EF4. Nobody knows that. When I did that tornado watch, how many people at 3 p.m. Central Standard Time on December 10th said, you know what? I guarantee you 6 hours from now, there will be an event ongoing that we will be talking about years later. I did not hear one single person say anything like that. So The real world uncertainty is what I'm tasked with trying to quantify, because I do this every day all across the US, every day that I'm working. And, I'd say, considering everything, we can't be perfect. There is no way to be perfect. So I think within the reasonable limits, I'd give SPC a 9 out of 10 on how we handled that overall. Perfect world, and especially the short term. We could have been a little bit more aggressive a day or two earlier with the convective outlooks. And you can always argue, perfect world, I would have upgraded a high risk in a narrow corridor. But, and notice I did not go PDS tornado on that watch, but I went with the highest possible watch. If we'd done anything else differently, it would have been a particularly dangerous situation. I talked with my coworkers 2 different times. I talked with the forecasters on the conference call for that watch, because I talked with all the offices affected before we issued the watch. Nobody thought it was quite to the level of a particularly dangerous situation. Because there were no storms, we just weren't quite that confident. So I went with the highest watch I could do. Perfect world, I'd love to have that back and call that a PDS tornado watch. But I was right on the cusp of it. You can look at the watch wording, the watch probabilities. It's the highest you can do and not call it PDS. So perfect world, we would hit the forecast even harder in the short term. But, I think that on the evening shift, they did an outstanding job with focused mesoscale discussions right as that storm was cranking up, saying, hey, this is where we think the focused, strong, and violent tornado potential is going to be. Oh, we think it's happening. We think it's going to keep going. They kept updating that. They don't think they ever went any more than 45 minutes or an hour between mesoscale discussions for that corridor. And, I'm proud of the way they handled it. And the evening shift had like 8 other watches that they had to do besides that one. So as you say, there wasn't just one tornadic storm. There was a bunch of severe weather. So overall, I think SPC did really well. And I don't reasonably think we could expect to do a lot better, because anytime you work these events, and again, this is from my experience, there are just so many unknowns. It's easy to say what you should do when someone gives you the answer after the fact. But when you don't know the answer, the people who tend to be like, oh, well, I would have gone high risk, I would have done this and that. I've got an open invitation to meteorologists. Come to the SPC and show me how you would do it. And I guarantee you sit there a couple of days, you put out a couple of really bad over forecasts if you forecast that way. Because you're going to say everything looks like the end of the world, and then, there were no storms. Oops. Do you know how much bad attention you get if you put out like a moderate risk with no thunderstorms in it? There's nowhere to hide. There are tens of thousands of people providing you feedback on these things. And they expect more of you. So my short answer is I think SPC did really well. There's a couple of small things we could have done better, but those were very difficult things to confidently do. So yeah, I'm hard on myself in the aftermath, but I think that I did as well as I could reasonably expect to do, and I think my coworkers did an excellent job with the rest of it.
Well, I think the office as a whole did an absolutely outstanding job. When you go back and really look at the messaging that we put out, to the products that we put out, the social media posts that we put out, I could spend an hour highlighting all of the different things that our office did to make sure that people knew what was expected to happen. And so I think that we did a phenomenal job of that. The warnings, in my opinion, could not have been better. I mean, we had lead time, our office never issued a tornado emergency before. So that was the first tornado emergency our office has ever issued. So you're going in uncharted territory there, and they did it flawlessly. Springfield, the office of Springfield deserves just as many kudos as we do, because they were able to pick up and put out those warnings and make sure that the service was not disrupted, and that saved lives. They saved lives, being able to help us. Not to mention the weather enterprise is one of the reasons why this This was, it could not, it could have been worse. Meaning, our office combined with the job of the broadcast meteorologist on various TV stations that were broadcasting that night, and the work done by emergency management prior to and during the event, that's what saved lives. It's not one entity in and of itself. It is a combination of many different entities. But it doesn't start with just issuing a warning, right? You've got a lot of work to do beforehand. The spotter training classes, the safety classes we put on, all of it adds up to where, when you put out something and you say to people, this is going to be a day that you're going to want to pay attention to. All of that work leading up to an event like that, where people know what to do, they know where to get information, they know what a warning is, they know what to do in a warning. All of that is preparatory work that we have done over the last 2 decades. That kind of culminates to this particular point, because I believe that if it weren't for that kind of work that happened, we would have seen a lot more people that would not have made it.
However, before I close this out, there were a few controversies surrounding the event that I need to discuss before I formally close this. 2 of those regarding companies, and the other 2 relating to the weather community's thoughts on the outbreak. The biggest controversies from the outbreak consist of what happened at the candle factory in Mayfield and the Amazon warehouse in Edwardsville. A few days after the Western Kentucky tornado occurred, workers at the candle factory in Mayfield spoke out about the managers at the candle factory who allegedly were preventing people from leaving the building during the tornado. The workers claimed that managers threatened to fire those who would leave. The factory had a history of OSHA violations, with 12 of them being filed in 2019 alone. A class action lawsuit was issued against the company, and at the time of recording, the lawsuit is still ongoing, so anything past that is pure speculation.
Just for those outside the U.S. who don't know, or who are in the U.S. and you still don't know, OSHA is the Occupational Safety and Health Administration, and they oversee basically the safety of all workers in the United States and all companies. So 12 OSHA violations in 1 year, that's extremely high. Most companies don't even get 1 in 1 year. So for a factory to have 12 is just, that's just insane. That's insane.
Amazon workers alleged something to a similar extent in Edwardsville, with the driver claiming that if she didn't finish her deliveries and went back to the warehouse, that she would be fired. Amazon spokespeople said that the person in question who threatened to fire the worker did not know proper safety protocol regarding severe weather, and that the driver should have been allowed to return to base. However, the controversies within the weather community are the only things that I ever hear about this tornado outbreak now.
Same.
One more so than the other.
Same.
Normally, I like to keep these documentaries factual, and if I say something descriptive, it's backed up by factual information. However, because I know I am going to see so many comments about whether or not the Western Kentucky tornado was an EF5 or not, I feel like I should give my 2 cents on this issue. The first and less talked about one was that the SPC should have issued a high risk for the event. This topic did not last long, as the people who said this constantly overhype literally everything, and that it's easier to think what to issue after the event has already happened. The general consensus is that the SPC handled the event perfectly. How?
Exactly. The people that say that they should have had a high risk are people like Ryan Hall, Max Velocity, Direct Weather, POW Ponder on Weather. They overhype everything. Everything. For example, one of the bigger headlines that just recently came out from one of their channels, it's very clickbaity sounding. A monstrous historic winter storm is on the way. Like, how do you know it's going to be historic? Oh, well, that's what the models are saying. They're models. They're not perfect. Trust me. The overhyping on the internet has actually resulted in some bad forecasts being issued by the SPC. There was a high risk one time issued in Lincoln County, in eastern Missouri and western Illinois. Guess what? Nothing happened. Nothing. There was a PDS tornado watch And nothing happened. Nothing. So, now what? Then there was another day where there was only a marginal risk in place. And storms, actually this happened recently on October 30th. There was only a marginal risk in place across northeast Missouri and west central Illinois. And thunderstorm activity exploded and became destructive, including wind gusts in some sections of Quincy that exceeded 85 miles an hour in Adams County, Illinois. They weren't calling for destructive winds. Yikes. You know, there's issues. But on this date, I agree with him. The SPC handled this as good as they could. With the information that they had available, they did everything correctly. When they issued that watch, they knew something was going to happen. They just didn't know how extreme things were going to get. Because there was just no storms. There was no activity in that area at the time. And they didn't know if it was going to happen within an hour, 2 hours, 3 hours. They didn't know. They did not know. They just knew that something was going to happen. However, here's the bigger controversy.
However, the major topic of conversation is whether or not the Western Kentucky tornado was an EF5 or not. An uncomfortable amount of people think that the National Weather Service intentionally rated this an EF4 because reasons.
Reasons such as the stuff that I have heard. In order to save the government from having to pay out as much money to victims. Or because the National Weather Service at the time was run by a bunch of Republicans. Just stupid political reasons. Stupid, politically charged reasons. It's sad to think that people say things like that. There is an uncomfortable amount of people that think that that tornado should have been EF5. Uncomfortable. I mean, there are thousands of people that have said that. Thousands. And my response to them, it's a fucking rating. It's a rating. A number. You're spending more time arguing about a flippin' number than looking at the fact that 57 people died. Over 600 were injured in this outbreak. And then that happened 2 weeks before Christmas. But instead you want to look at the flippin' number. The number. The EF4. I don't care whether it was an EF2 or an EF0 or an EF5. Heck. St. Louis was hit by an EF3 in May of 2013. That thing still proved to be deadly. There's been EF2 tornadoes that have killed people. Heck, there's been straight line wind events that have killed people. It doesn't matter what rating it was. It's a number.
Some people's evidence saying that it was an EF5 is, look at the damage. Now, others believe it was an EF5 and show actual potential evidence backed up by engineering and math calculations. The most important piece of evidence was the damage done to the Mayfield water tower. The tornado's center went straight through the Mayfield water tower, causing it to completely collapse. The water tower was well built, and the structure failed due to strong winds. Meteorologist and structural engineer Ethan Mority did a wind speed estimate and found that it would take winds of 203 miles per hour to make the water tower collapse. However, this is not exact because there were assumptions made about the dimensions of the water tower.
Again, assumptions. How many times do I have to tell people that assuming things is bad? It never works. It never works.
Other piece of evidence being the extreme ground scouring observed from the tornado. So, what?
Now, that is a potential piece of evidence. Because the ground scouring was pretty intense. As he said, up to a foot deep. In fact, it was so severe that even now you can still look at Google Earth images and see in some of the forested areas holes, pits, and trenches that were produced by this tornado.
It's my view on the issue. My answer as to whether or not the Western Kentucky tornado should be rated as an EF5 is... I honestly do not care because the rating is fine as is, and more emphasis should be put on the people who suffered from this outbreak. My reasoning as to why I think the rating is fine as is as follows. First of all, is that the Western Kentucky tornado was rated as a high-end EF4, which, if you compare the damage photos between a high-end EF4 and an EF5 tornado, to the untrained eye, the level of destruction from a low-end EF5 like Joplin and a high-end EF4 like the Western Kentucky tornado seems to be virtually the same. It's so easy to say something looks like an EF5 without taking into account the construction quality, which is taken into account specifically to avoid tornadoes from being overrated. The overrating of tornadoes has its own problems, and that is a can of worms I am not going over here. It's not like the Western Kentucky tornado was given the same rating as the Noonan EF4 from that year, which some argue should be an EF3. Why do I even do this? I know I'm gonna get stupid comments about that. People treat the high-end EF4 rating as the end of the world and that there is some massive difference between a high-end EF4 and an EF5, when there really isn't.
I'm totally with him on this. Like, everything he's saying is like 100% perfect. Like, right there. It's just, it's perfect. I mean, the construction quality is taken into account specifically to keep tornadoes from being overrated. Heck, if this thing had been rated as F4, tornado wind speeds would have been in excess of 260 miles an hour. However, the reason the EF scale, or enhanced Fujita scale, was introduced in 2007 was because tornadoes were consistently being overrated. The two tornadoes that come to mind that I can think about easily showcasing this problem firsthand were the Gerald, Texas F5 of 1997 and the Bridge Creek, Moore, Oklahoma tornado of May 3rd, 1999.
A high-end EF4 is a fine rating, and a high-end EF4 tornado is still exceptionally rare. Secondly, the tornado was rated with the EF scale. The scale is a tool to estimate wind speeds in correlation to damage. The EF scale was used correctly in the damage surveys. Many of the points of possible EF5 damage were decided to not be worthy of an EF5 rating because it was done using the EF scale exactly as it was intended to be used. Of course, it comes down to the EF scale having problems, but it's not like the NWS doesn't know that. We've known this since Joplin. The EF scale has problems, lots of them, and since 2015, members of NIST, the NWS, and ASCE have been working on a fix to the issues present in the EF scale. I addressed this back when I interviewed Dr. Fawn for Gerald, and if you want to listen to what the problems are with the scale currently from someone who was influential as to why the EF scale exists in the first place, listen to him.
Basically, what he's going to say here, and I'm going to fast forward through it because he has an accent that makes it kind of hard to understand.
Forward 10 seconds. Next video. Track position. 1 hour. Next video. 60%. Track position. Characters.
What he is actually saying. But basically what he's trying to say is the scale still lacks the quality damage indicators for certain types of construction. In other words, it just needs to be adapted to the changing times. Not to mention it doesn't take into accountability the Doppler weather radar wind measurements. For example, that's why El Reno, Oklahoma was not rated EF5, because even though there was a Doppler weather radar mobile station that measured a wind gust of 300 miles an hour, there wasn't enough damage to correlate with 300 mile per hour winds. Instead, the damage peaked at EF3, well below 300 miles an hour. In fact, the damage was more likely around half that of 150 miles an hour.
Investigation of the 2011 Joplin, Missouri tornado, we concluded that for this procedure, take one responsibility, make available data.
The people, third and most,
It would be another improvement to the EF scale. So that's where we are moving forward to.
third and most importantly, I have never done a damage survey in my life, and I can assure you, most of the people saying the tornado should have been rated an EF5 have not either. The people who did the damage surveys for the tornado included people with master's degrees and PhDs in meteorology or engineering. It is not in my right to argue with people who have spent at least 8 years of their life studying and mastering their craft of analyzing tornado damage when I have little knowledge about how damage surveys work myself.
Amen.
Essentially, the rating is fine. Could the Western Kentucky tornado have had winds that correlate with an EF5? Yes, definitely. There is some evidence suggesting that. Are there problems with the EF scale? Yes, and it's being addressed, and it is not worth arguing with people with tons of experience in surveying damage over a rating. The rating of the Western Kentucky tornado does not change the fact that it is still one of the worst tornadoes in recorded history. Despite the EF4 rating, it is still one of the most infamous tornadoes in history. So my real question to people mad about this is, why? Why is this such a massive issue? I'm genuinely curious here, as I cannot understand why this is so important to people. During the days following the outbreak, I saw more people in the weather community concerned over the Western Kentucky tornado being an EF5 before the damage surveys were completed, instead of the devastation it brought to the people of Kentucky, something that I find disgusting. It's absolutely fine to have the conversation now, but immediately after a violent tornado, the conversation comes off as distasteful to the people who were affected by the disaster itself. The people who survived are going to be terrified of tornadoes for the rest of their lives, and yet some people only care about a tornado, stupid.
Yeah. Honestly, I've seen similar things happen in 2022, and 2023, and 2024. It happens all the time. It happened after Rolling Fork, Mississippi. It happened after Little Rock, Arkansas in 2023. It happened after Wynne, Arkansas in 2023. It happened after Iowa City and all the March 31st tornadoes in Iowa and Illinois in 2023. It happened in 2024 with the stuff that happened in Nebraska and Iowa in April and May. It's disgusting. It's honestly disgusting. It happened even before December 10th. It happened in 2020 with the Nashville and Cookeville, Tennessee tornadoes in March. It's sad. It even happened last year in December on the 9th through the 10th outbreak that saw tornadoes ravage Tennessee, including a monster EF3 that was on the ground for over an hour, starting near Clarksville, Tennessee, and tracking into Todd County, Kentucky. People argued that should have been an EF5. It's a rating. It's a number. It's a number.
I should stop before I go overboard. I had to get that off my chest. Before I go into the conclusion, both Christine Welgos and Richard Thompson had final messages about the outbreak that they want to leave people watching this video with. This will take a while, but I'd seriously consider taking a hard listen to it, especially to what Thompson has to say. Hey, so this is Alferia while in the midst of editing this, and yes, this has been painful. I need to establish some context regarding the final comments from Thompson, so this is why this segment is here. So earlier in the interview, that wasn't shown in the video because if I were to include every single segment of an interview in a video, it would be 3 hours long. The topic of the expectations from the event from people outside of the professional weather space came up. I mentioned that someone from Force 13 US, which I was part of at the time, said that the event was going to be historic before the first tornado even formed. That led to a brief conversation regarding the people who constantly hypecast events that ended up getting a larger voice because of the December 10th event, treating it as like they were right the entire time and the SBC doesn't do anything right because, those people only have profits in mind. And then it led to a smaller conversation about the number of weather personalities online who constantly overhype events 24/7, like the world is about to end, and how the excuse those personalities give is that they are they're spreading the word of the NWS and SPC when they are obviously not doing that and are in fact hurting the NWS and SPC in the process. We ended up having a longer conversation about that after the interview concluded. So if I didn't budge in now and, I just let things go on as it is right now with the video, the final message from Thompson would make no sense to the average person. So I wanted to have this make sense, and I also think that his message is still very important, even if it doesn't make sense initially without the context, because it is something that I think everyone in the weather space online really does need to hear. So that being said, back to Thompson.
Well, I think that the thing that I would like to leave viewers with is that, we've improved the tools that we use to forecast. And because of the work of a lot of meteorologists and weather enthusiasts in the background, these tools are widely available for free for people to use. The thing that isn't as easily accessible is the proper training to know how to use them. Anybody can look at a simulated model reflectivity forecast. It's meant to look like a radar image and just say, oh, well, this is truth. This is exactly what's going to happen. I challenge anyone to look at that in detail day after day and account for the errors in those forecasts and go, wait a minute. There are what looks like a big mesoscale convective system is forecast and there's no storms anywhere near where it is. Or other times there's no storms forecast and you get something like that. Or there's a supercell, but yeah, it's 100 miles away from where it was forecast to be. All of those things matter to the outcome at the ground. It certainly mattered to Mayfield. If you shift that storm track 10 miles north or south, the way you talk about that event changes because first of all, the town name, you wouldn't say Mayfield. And that would be great for the folks in that town, but it might be terrible for somebody else somewhere along the path. And we don't know that level of detail. We do not know tornado longevity and intensity with extreme detail prior to the occurrence of the tornadoes. We're getting better at identifying, I think it's happening right now, but that's a big difference than saying 6 hours ago or 3 days ago, we knew this was going to happen. You did not know. Anyone that says they knew is lying. They're just uninformed, inexperienced, and they need to come sit in with me at SBC and show me how they do all this stuff. And I guarantee you I'll poke 1,000 holes in that boat before the end of one shift and they'll be done with it. And so it's just that I think while we've made tremendous strides in meteorology, we don't know every single thing we need to know. And the forecast tools, despite how enticing they look and the guidance that we have, it's not perfect. So your friends or whoever, when they were saying, oh, well, it's going to be historic, I know. How many times do people say that same thing and they're completely wrong? They don't follow up on it. Me, as an SPC forecaster, I don't have that luxury because if I say that, my name is on that forecast and I have to live with it. And it's archived forever and ever on the internet and people can call it back up and I can't really explain it away. So if I want people to take it seriously, and like you, I try to approach it from a conservative perspective. I don't want to cry wolf. I want to detect the big events, but I don't want to be like, oh, there goes Thompson again, putting out a high risk because he's done it 18 times this year. any of the weather enthusiasts would immediately know that we don't have that many high risks. This guy's overdoing it. I don't want to be like it. I want it to be the first thing that people say when they look at products from SPC is like, wow. Like if they see that upgrade to moderate risk or they see a tornado watch or whatever, the first question they ask themselves is like if you're saying, if they're not paying attention, they go, wow, this is more serious than I thought, or wow, okay, this could be bad. I don't want them immediately saying, oh, I don't believe this again. This is probably a false alarm. Or they're never right. I want it to be based on solid, factual verification that our forecasts are credible and they're reliable. And it takes a lot of work over a long period of time to do that. And it doesn't take very long to undo it. So when you say that people are saying other stuff, you're right. They think that, oh, well, they're just passing on the message. They're making it more difficult because what they're doing is they're trivializing what goes into the forecast in the background. These are people that are have dedicated their lives to doing this stuff and have spent decades working on it. And they take it seriously. And so, I just want everyone to know it's still not that easy. You may think it is, but get out there and actually hold yourself accountable for the details of your own forecast. And I think you'll see pretty quickly that we still have a lot of improvements we can make to the forecast, and nobody knows what's going to happen. So you just got to, balance all that stuff. That we can do an amazingly good job compared to 25 or 50 years ago, but that does not mean that the problem is solved. The Earth's atmosphere is one of the most common or complicated things that we'll ever deal with outside of the entire universe or like the complexity of the human body. You can't expect perfection. We can strive for it, but you can't expect it, and don't think that we're anywhere close to there yet. So, and you have to take responsibility yourself. I can't come to your door and knock on it and say, oh, this is, hey, this is the one day where you really do need to take this seriously. You right here. I can't do that. So you've got to take some personal responsibility. And that's where I think it's important that we give a consistent and credible message so that they know, hey, wait a minute. They're not telling me to pay attention to the weather every day, but today's one of those days where people are bugging me about it. Maybe I should look at this. Maybe I should pay attention later today. Maybe this is going to be worse than normal. And in the case of the Mayfield Day, okay, it's December. Are they used to getting tornadoes in Western Kentucky in December? I won't say they're used to it. It's more common south of there. But guess what? It happened. And, we gave some indication in the forecast. So, it's a fascinating, difficult, science to work in, and doing this operationally is very messy, difficult, complicated, and we don't have it all figured out yet. There's a lot of room for growth in the science of meteorology.
Well, I guess
I can't say anything better than he did. That is the truth. That is so true. 25 years ago, people didn't think tornadoes happened at night. In fact, in 2005, a massive tornado tore through Evansville, Indiana. However, news stations and meteorologists were very hesitant to cover this tornado as it was happening. Why? Because it happened after midnight. And pretty much everyone's way of thinking was, oh, tornadoes don't happen at night. Well, that tornado proved them very wrong. Very wrong. In fact, that's one reason why nocturnal tornadoes prove to be over 2 times as deadly as daytime twisters. Because there's still this myth that floats around that tornadoes don't hit at night. Another thing that was thought 25, 30 years ago, oh, tornadoes don't hit big cities. That's obviously wrong. Look at Nashville, 1998. Birmingham, 1998. Tuscaloosa 2011. Nashville again 2020. Little Rock 2023. You had Mayfield 2021. You had Bowling Green 2021. You had North Nashville 2023. You had St. Louis 2011. You also had St. Louis 2013. You had literally the south side of Chicago in 2021. There was a tornado that hit near Naperville. Obviously, tornadoes do hit big cities. In fact, Oklahoma City is a magnet for tornadoes. They've been hit a lot of times during tornadic events. They were hit in 2000, they were hit in 1999, they were hit in 2011, they were almost hit in 2013 with Moore, they were almost hit with El Reno in 2013. It happens, people. Another myth that likes to float around sometimes is tornadoes don't occur in winter. Well, they certainly do occur in winter. Yes, they're less common, but they do occur. I mean, again, December 10th, 2021, winter time tornadoes. December 15th, 2021, we had another massive tornado outbreak. In fact, it became the largest tornado outbreak in December ever. And actually, December then 2021 shattered the record for the most tornadoes ever seen in December. We had December 9th through the 10th of 2023. Tornadoes hit in Tennessee. We've had December 31st, 2010. A tornado outbreak ravaged the St. Louis metropolitan area and areas south and even north of that area, with severe storms slamming sections of St. Louis, including a tornado in Sunset Hills, Missouri. We had, let me think here. We've had other tornadoes that have occurred in winter as well. Yet, everyone still says tornadoes don't occur in winter. Well, now 30 years later, we know better. We're always improving. We can strive, as he said, we can strive for perfection. We can never get perfection. That's just never going to happen. It's not realistic.
I could just sum it up by saying that, the mission of the National Weather Service is the protection of life and property. That is why we're here. That's why I'm paid to do the job that I do. And so, our job to save lives is not solely, we cannot solely do it by ourselves. And so we rely on our partners. And that's why, I have the job that I do. And warning coordination meteorologist is the public liaison to the outside world. My job is to ensure that our customers and our partners have what they need to do their job, to make their decisions. And so collectively, as a whole, I think this is an event that really showcases when that is done correctly, when you have good partnerships with people and you've done your part over a long period of time to get people educated, to get people to respond to the messages we send out, to respond to the warnings we send out. I think that's when you can be the most successful, is when you don't give up, and you keep working with people. And some of the things that have come out of this event, for instance, we're working with the Spanish-speaking community. We're working with trying to get into our Amish communities to see what we can do to help educate them and make sure they have some way to get information on the weather, stuff like that, we're working toward increasing our reach, so to speak.
Now that is over with, let's wrap this up. The December 10th through the 11th tornado outbreak is often remembered for what it did in Mayfield by the public. It's easy to understand why that was the case, because Mayfield was the largest city to be hit by the tornado. However, only focusing on the effects in Mayfield is a disservice to what happened to the other communities that were devastated by not only the Western Kentucky tornado, but from the other tornadoes of the outbreak. The Western Kentucky tornado brought its wrath to many other areas. Dawson Springs, Bremen, Casey, along numerous other smaller communities. Those areas deserve to have their names recognized for what the tornado did as well, alongside Mayfield. The other tornadoes of the outbreak are still worth talking about. The devastation brought to Dresden, Tennessee, and Pembroke, Kentucky. The damage brought to Lafayette, Kentucky. The tornadoes in Bowling Green, Kentucky. The tornado north of St. Louis, and the tornado southwest of Edwardsville. All of the major tornadoes from that day deserve some spotlight while discussing this outbreak. Yes, the Western Kentucky tornado is important and the strongest tornado of the outbreak, bar none. But the outbreak is so much more than Mayfield, something I hope to have established by this point. The people across Kentucky, Tennessee, Missouri, Arkansas, and Illinois have been scarred forever from this outbreak. Their pain should be heard, and the efforts of ordinary citizens to help the victims through these trying times should be given more notice and priority in the conversations about this outbreak, instead of the constant bickering about a tornado's rating. That's my thoughts on it, and I know I'm in the minority about that issue. While portions of Kentucky have been rebuilt, the towns hit by the tornado are visibly different today than they were before, with some areas still unrecognizable. Nearly 9 months later, the scars left from this outbreak still remain across many areas affected by the tornado outbreak that occurred from December 10th through the 11th, both physically and psychologically. The December 10th through the 11th tornado outbreak is one that surely will not be forgotten anytime soon, with a legacy that will last for generations. Okay, so I want to go a bit further in depth as to why I didn't want to do this initially. It boils down to the point from the last video about how everyone is doing one. A lot of people have been planning on a documentary on the Western Kentucky tornado for a longer time than I have, and I don't want to be seen as the guy who does a Mayfield documentary because haha, free views. Especially when I had no idea what to add that hasn't already been said, with the exceptions of the other tornadoes that I covered outside of the Western Kentucky tornado, since there haven't been any good videos on those tornadoes. But thanks to the interviews with the SBC and NWS, I finally had a reason to do this documentary. I cannot thank Richard Thompson and Christine Wilgos enough. I loved talking to the both of them, and they were instrumental in making me want to do this documentary, alongside giving me advice regarding my hopeful future career at the National Weather Service. The people who got me in contact with Richard Thompson were Dr. John Knox from the University of Georgia, who got me in contact with Tim Coleman initially for Gerald, and then Tim Coleman put me in the direction of Richard Thompson. I cannot thank Dr. Knox and Tim Coleman enough. Special thanks to CMR on Discord, who got me in contact with Christine Wilgos, and her perspective really helped because she was able to tell me what the NWS did and expected from the event. So, I can't thank her enough. It was just fantastic. CMR also wrote an in-depth article about the Western Kentucky tornado, which was a useful reference for this video for talking about the damage path of the Western Kentucky tornado. I also want to thank him and Flappity for providing me with radar loops of the storms I covered. Special thanks to my proofreaders, that being Rishi, Flappity, John Wright, and Alice. May the Lord bless their souls for proofreading my longest script yet. Yet again, special thanks to CMR, Dr. John Knox, and Tim Coleman for getting me in contact with the interviewees, and thank you to Richard Thompson and Christine Wilgos for agreeing to be interviewed for this video. Of course, thank you for supporting me, even if some people wouldn't stop asking for this. Huge thanks to the people subscribed to the channel Patreon, including Montpelier, who is subscribed to the Alfie's Army tier, and Avery Toyota, who is subscribed to the Elf Mini tier. For those who want to get videos as to how I create these documentaries alongside some editing tutorials, consider joining the Patreon. At the time of recording, there aren't any videos on the Patreon, but I'm gonna try and fix that after I upload this. I have an announcement to make regarding the Sandy documentary. I want everyone who watches the content I make to make a video of yourself talking about what you experienced during Hurricane Sandy, if you experienced it, and the damage that you observed. Sadly, I do not think I will get the Jay Schlatt interview, but at least I tried. There will be a Google form that I will set up in the description where you can upload the videos of what you have filmed, and as well as, yourself talking about the storm itself. I will use those videos throughout the documentary. If you enjoyed the video, make sure to like, comment, share it around, all that jazz. I know a lot of people are going further in depth than I am about this subject, and I wish them the best of luck with it. The people in question are DFW alongside Johnson and a bunch of other people, and I will promote their video when they release it, as I know they are putting much more time and effort into this than I ever could. Anyways, that being said, I'm Alfaria. I hope you all enjoyed the video, you all have a good one, and make sure to stay safe out there.
gotta say, much respect to Alfieri. Got to say, I mean, that just... Alfieri, if you're watching, your channel is amazing. 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 I love the weather documentaries you do. It's, you know, I'm going to quote Richard Thompson here, I'm a weather weenie. That's kind of what I am as well. I've loved weather since I was 8 years old, and now that I'm 22, I don't see any sign of me slowing down my hobby. Anyway, guys, that's about all I have for this video. I hope you all have a blessed day, and you all enjoy yourselves. Until next time, friends, Central Arkansas EAS, signing off.